Thanks, everybody. So today I will be talking about Core Data. Core Data is Apple's data persistence framework that they make available to developers on all of the platforms. So that means that you can use Core Data in your iOS apps, watchOS apps, tvOS apps, or macOS apps. The reason that I want to talk about Core Data today is that when I tell people that I actually really like Core Data, is that they often ask me why, or they tell me how much Core Data sucks or how horrible it is. And I really think it's not. So I want to tell you why today. It's especially older developers that tried Core Data like 10 years ago that have very bad experiences. So if you're one of those developers, this talk is for you. If you're a new developer who just heard from somebody else that Core Data is complicated or convoluted, and you're using Realm instead because that's supposed to be easy, this talk is also for you. So, my purpose today is not to convince you that Core Data is perfect or that it's a one-size-fits-all solution for all your data storages. Let me make that clear up front. It might make sense for you to use something else. But if it doesn't, here's what we'll go over today. I'll first show how you can set up a Core Data stack. Then we'll see how you can update your Core Data model once you've defined it. If that sentence doesn't make sense, don't worry, it will by the time that we get there. Then I will show you how you can use a very complicated Core Data setup using several managed objects contexts. And lastly, I will show you how you can measure and optimize performance of your Core Data implementation. This is a lot to cover, so let's just jump straight into setting up your Core Data stack. So if you've done Core Data before, you might expect a huge amount of code on this slide. Surprise, this is all you need, ever since iOS 10 actually. It's been a while since Apple introduced this, and a lot of people are not aware of NS persistent container. It only takes a handful of code to set up all of your Core Data objects. If you don't know what those objects are, it doesn't really matter at this point, because you can just use the persistent container as is, and most of your Core Data management things are taken care of automatically. So for most apps, setting up Core Data is just a handful of code. So in addition to setting up your Core Data stack, you need to define what data you're going to store in Core Data. To do that, you use the model editor. Now there's nothing new here, but I still want to show you what it looks like. So in the model editor, you define the entities that you're going to store in Core Data and their properties. Now what's interesting here is the attributes inspector. It shows different options for your model attributes, your relationships, or your entity. So I want to show you the attributes inspector. So what you configure here is pretty basic. It's your duration, it's whether your attribute name, in this case duration, is whether the attribute is optional or not, and a couple other values. For relationships, the attributes inspector shows something different. It shows the name of the relationship, whether that is optional or not, and the destination, inverse, and delete rule for the relationship. The delete rule, if you don't know what it is, it describes what happens with the object at the other end of the relationship when you delete this object. So before I go on, there's one really cool feature that was added to Core Data or to the model editor recently. So if you have ever worked with Core Data, just defining your model is not enough. You also have to write a managed object subclass. That means that you're going to have to redefine everything you just wrote in the model, all the configuration that you specified. And that's no fun. At least I think that's no fun. However, if you look at the inspector for an entity, you will find this little drop-down here, the code gen drop-down. Now, what's super cool about this is that the code gen drop-down allows you to configure how Xcode is going to generate a model class for you. So if you put it on class definition, you don't have to write an NS managed object subclass yourself. Core Data will do this for you, or Xcode, really. One note, though, if you let Xcode do this, it will put the generated class in your derived data folder, And you should not modify that file because it will be recreated every time you build your app. So now you know that it only takes a handful of code to set up core data in your application, and also that you can define your models quite easily. So let's turn that into an app. Most apps that I have worked on will at some point fetch data from the database and show that in a table view or a collection view or whatever fits best for that app. It's a good thing that core data makes that easy for you, and I will show you how. You can do this using a fetch results controller. A fetch results controller takes care of basically everything to make sure that a table view or collection view, or really just anything that will observe the fetch results controller, remains in sync with the data store. To set up a fetch results controller, you need a couple of things. The first one is a fetch request. A fetch request describes what object core data should fetch from the database for you and a bunch of properties. So in this case, you're looking at some code that requires all schedule items for a conference app to be fetched, and it will sort it by the conference's name and also by the start time of the schedule item. Other things you might want to set on a fetch request would be, for instance, a predicate to filter out some data, or a batch size or fetch limit, to make sure that core data only fetches a certain amount of items. So once your fetch request is configured, you can create your fetch results controller. The initializer for a fetch results controller takes a couple of parameters. The first one, your fetch request, so the controller knows what data to retrieve. The second one is a managed object context. In this case, the view context from the persistent container is used. I will explain more about the view context later. The third parameter is a very interesting one, especially cool if you're using a table view. Fetch results controllers can automatically split the results from a fetch request into sections. So in this case, the conference app that I built as a sample for this talk can have many conferences in it, and I would want to have a table view header for every single conference. So I can use the conference name as a sectioned key path. Lastly, you need to set a delegate on your fetch results controller. Whenever the underlying data changes, the fetch results controller uses delegation to inform you about that. Once you've got all the setup done, you can perform a fetch with your fetch results controller and perform your initial reload on a table view. So if we look at that in a different way, we can look at it like this. There's a data store, there's a fetch results controller, and there's an app. Now you might think that's like, 5 talks? There's way more today. And that's right, I did this on purpose because I wanted to show something cool. Let's say for some reason the underlying data store updates. Maybe you're making an API call in the background. New speaker data comes into the underlying data store. The fetch results controller will notice this. And because it uses delegation, it will automatically update the table view. No extra work needed. It's almost like magic. Dave DeLong would be happy. So what does that delegate thing look like? Because obviously it isn't entirely magical. You need to do something to get this to work the way you want it to work. There's 3 delegate methods that you need to implement. The first 2 are super easy. They are controller will change content and controller did change content. These are called as soon as the controller knows that new data is available, because the underlying data store changes. Once it did that, it will call another method that we'll get to in a bit. And once all the updates are passed on to the delegate, it will call did change content. So these 2 methods are perfect to start and end your table view updates. The third method is kind of long and it looks very complex. But if you take a second to read it, I will take a sip of water and you'll realize it's not that hard. So this method is called for every object that changed. That means a new object, an object that moved, an object that was deleted, or an object that was updated. So it receives 4 arguments. The first one being the controller that called this method. The second one, the object that was changed. And the third one is an index path. Now this index path, if it exists, is the index path where the table view or collection view should currently be able to find the object. So if you're dealing with a new object, of course index path would be nil because the table view doesn't know where to find it. The new index path that you'll see as the last argument is the index path where the object should be after the table view is done updating. So that switch statement there just checks what kind of update is this? Do we have the index path set? It should be set for the appropriate cases, and then the table view will be manipulated accordingly. So this is great. I mean, I just showed you in just a little bit of code how you can build an app that shows items for a conference and that's able to react to changes. However, that data model that I showed you, you might want to update it. So you can ask, but what if I want to do that? And if you have written core data stuff before, you would say, I'd have to do a migration, right? Like, I have to do stuff, I have to do work for this. What you would have to do in the past is, it looks like this. So you add a new model version, you give it a name, you make sure that that new model version is the current model version, and now you can go ahead and make your changes. While this is not a very lengthy process, there's a bunch of steps and it's easy to forget. I cannot count the amount of times that my app has crashed on development stuff because I forgot to make a new model version. So let's see what this process would look like in a modern core data app. So nothing was cut out of this video. It's as easy as just adding the new property. Core data will automatically see that a new property was added and migrate your database accordingly. While this is really cool, of course there are a few rules to automatic migrations. It only works for simple changes, adding properties or removing them, or making a non-optional property optional if you provide a default value. If you don't do this, you're still going to have to make the model version. You're still going to have to write a migration. But in my experiences, most changes you make to your data model are simple changes. And even though this is great, make sure to always test this. If you already have your app in production, make sure to put that production build on your device, then put your new version on the device to see if the migration was generated correctly. So this was the easy bit, the introduction. Now let's see what a complex setup would look like, a multi-context setup. So I already showed you basically this, a view context with a bunch of objects. So anytime you work with core data, you are doing so in a context, a managed object context. And every object that you would fetch from the database belongs to a context. They're tied together. They're not supposed to be teared apart. The cool thing about the view context, though, is that it's doing its work on the main thread. So this allows you to fetch something from your database and use it in your UI. The downside is that if you want to fetch something from your database and it's a very slow query, or you want to write data to your database and it's a lot of data, or you're doing complex processing, this could block your UI. So for that purpose, you might want to use a background context that does all of its work in the background. So let's say you have this situation. You have your view context with the fetched objects in it. You're creating a background context which you're using to pull in data from a remote server. So you have your inserted object because there was only one change in this case. You might be tempted to just throw that over to the view context. This doesn't work that way. Your app might not crash immediately, but eventually you will get some very obscure crashes that can be very hard to track down. So instead, we do everything through the persistent container. When you save your inserted object to your database, it's automatically observed by the persistent container. And the persistent container, in turn, will update the view context. So this is all handled for you. You don't have to do manual work to get this to work. So another way to look at this. Oh, sorry. I'm running ahead of myself. If you want to use a background context, you can either create a new one or obtain one from your persistent container and do work on it like this. Use the perform block. Alternatively, you can just tell the persistent container to do work in the background. The first method is useful if you want to have a background context that stays around because you're going to use it a lot. The second one is convenient for simple, quick jobs that you want to do in the background. So looking at this from a different perspective. If you create a background context, it exists as a sibling to the view context, and the persistent container acts as a parent. So when you save data to the persistent container, it will look for children of itself that have the automatically merges changes from parent property set to true. So if you set that to true on a view context, it will automatically get the new changes and it will work like magic. So in this case, the fetch result controller will see that the view context changes and it will be able to relay any changes over to the UI. So that's how you can use a multi-context setup. Again, it seems very complex and it used to be very convoluted, but nowadays it's a lot simpler. There's less overhead. This is all manageable, even for people that don't use core data all the time. So there's one more argument against core data that I have often heard, and that is performance. Now, core data is a database, or more, an object persistent graph that uses a database under the hood. And like any persistent framework or any database, if implemented and used poorly, it will be slow. There's not a single database that will automatically have great performance no matter what you throw at it. The same is true for core data. And I want to show you two ways in which you can make sure that your core data implementation is working well. The first one is to make sure that you analyze your implementation using instruments, and the second one is to use some debug flags to get debugger output. So let's look at optimizing fetch requests with instruments first. I'm going to do that with the conference app again as a sample. And this is instruments output that you could get if you run that for instruments. Now, this might not mean much to you right now, so I'll explain what you're seeing. If you do a fetch request in core data, it will fetch as little data as it can. So if you have, like I have in this app, a bunch of conference items and talks and speakers, it will not fetch all the talks and speakers that are attached to an item until you need them. So once you access an item, core data will try to fetch it from its cache, and when it has a cache miss, it will go to the database to fetch it. So what you're seeing on this slide are all the cache misses that core data encountered for the conference app. So even there's only a couple of objects in the database, it has to go and fetch every item. Then for every item, it goes to the database to fetch a talk. And for every talk, it goes to the database again to fetch a speaker. So that means that for one item in the list, there are 3 database queries done separately, which might not be horrible in a small app, but just the thought of it makes me kind of nauseous. So what can we do about this? Well, we can tell core data what we're going to do. Like sometimes we know that a relationship is going to be traversed every time. So if that's the case, you just tell core data to prefetch what you need. So in this case, tell core data to prefetch the talks and all the speakers for every talk. And if we run the same app through instruments again, the cache misses are empty. They're gone. Now, you might think that we reduce the amount of queries to 1, which is also not true, because it's actually 3. But how do I know this? Well, I know this because I can analyze queries. I can set a debugger flag so that all the queries that are sent to SQL are printed to the console. So what you see here is all the core data related logging in the conference app. If you look closely, you'll see that there are 4 queries being executed. One is to fetch all the conference items, one to fetch all the talks at once, and one to fetch all the speakers at once, and then the last one is to fetch all the table view headers. So that's much better than I don't know how many queries it would have been, but probably around 50. 4 is way more efficient. Now, sometimes you might want to know more than just this. Sometimes you might want to see the explain output for an SQL statement or a bunch of other information. You can obtain this by changing the debug level from 1 to 4 to get everything Core Data wants to log to your console, and by turning on the standard error output. If you do that, you'll get a bunch more output that I won't show right now, but that will give you literally everything Core Data wants to log. So, in conclusion, I have showed you today that getting started with Core Data in your app is relatively simple. It's at least not as hard as it used to be. Updating your model, it's easy, because Core Data does all the work for you. Multiple managed objects, you can do that relatively simple too now. All you need to do is make sure that you don't mix threads. If you do something on a background thread, keep it there. If you're doing something on a view context, keep it there. And lastly, performance can be tweaked tremendously. Just like any other database, you need to do your logging, you need to do your measurements, and make improvements accordingly. With that, I would like to thank you very much for having me. And if you have any questions, you know where to find me after the talk.